All right, welcome to our backyard session. We are going to talk today about how to solve linear equations. And I brought some of my closest friends here to help me. You'll get to hear them and maybe even see them a little bit later. So here's what we're doing. We are going to be looking at several problems that are on the algebra sheet. However, these are all odd problems. Which problems are due on the algebra sheet, Clara? All the even ones. So will these problems be actually part of your algebra sheet? No. All right. But they should still help because I know that problem 14 is exactly like problem 13. And I know that problem 26 is exactly like problem 25. And so on and so forth. So I've picked 5 problems that are similar to problems that I think you might struggle with for your algebra sheet. So let's get started. Before we look at these problems, I'm going to talk about some basic generalities. In algebra, we will never use x to mean multiplying. X will always mean a variable, an unknown that we need to find. So when we have a number right next to a parenthesis, what does that ask us to do? What does that ask us to do, Caroline? She just said multiply it. Your biggest, loudest outside voice that would drive Miss Lisa crazy. Try it again.
Multiply it.
Would that drive Miss Lisa crazy? One more time.
Multiply it.
There we go. That's the volume we're looking for. That's the volume we're looking for. Okay. So when you have a number next to a term in parentheses, you are to multiply it. Now, this is actually called a binomial because we have two terms meaning binomial term. So binomial, that's when you have two things inside a parenthesis, one grouping, it's a binomial. Obviously, they're going to be trinomials and then polynomials after that. So then, what's it mean with this fraction bar? And this is something I do all the time. What operation is represented by a fraction bar? Yes, Gavin?
Division.
Is Miss Lisa crying right now?
Division.
Muy forte!
Division. That's the best.
Division!
Thank you, Alex. Division. Okay. So this fraction bar means division. Right here we have a negative 1/2 next to the binomial x plus 4. Bear, what does that mean when that negative 1/2 is right next to this binomial?
I totally forgot.
That is amazing. Wow. Your forgetful power is even better than mine. Emerson.
Multiplication.
I like the shouting. Good job. Multiplication. So we're multiplying that negative 1/2 to this binomial here. And notice how in this last problem we have the added layer of complexity where we have a negative sign in front of the binomial x minus 5. But before we start talking about these problems in particular, we are going to just start with the basics. All right, who here likes games? Depends on the game. I don't care what the game is. You make the game, I will play it. Okay, we are playing a game. And the game is called Find the Unknown. That's the game. And I'm willing to bet each and every one of you likes games because you want to win the game, right? Okay, so this is a game that has a winner as well. And we all want to be a wiener. Winner, right? Okay, they're looking at me like I'm crazy. They've never heard a W pronounced with a V. Bad math joke, whatever. So we're all going to be wieners. Now, to be a winner, what you have to do is you have to get the letter all by itself on one side of the equal sign. That's what we're trying to do. Get the letter all by itself on one side of the equal sign. Now, Gavin's not paying attention, so I'm going to call on Gavin. Gavin, we have some rules of the game. Do you know the rules? Okay, what are the rules of the game? No. Getting the letter on one side of the equal sign, that's how you be a winner. But we need to have rules to play the game, right? All games have rules. So we have rules that we have to work with, and everybody can be a winner in this game. So here are the rules. Gavin, I'm going to call on you every time if you continue to pick your fingers with your pencil. All right, so here are the rules. I'm going to write a simple number sentence. Gavin, what's your favorite number? 8. Can someone give me a mathematical expression, an easy one preferably, that will equal 8? Who have I? Anya.
4 plus 4.
4 plus 4. All right. Now, obviously, she could have said 4 times 2, 1 plus 7. She could have said 10 minus 2. It doesn't matter. We're going with 4 plus 4, though. All right, so is it fair to say that 8 is equal to 4 plus 4?
Yes.
Everyone agrees with that?
Yes.
Okay, so here are the rules. You are allowed to add, subtract, divide, or multiply anything you want to one side of the equal sign, as long as you do exactly the same thing on the opposite side of the equal sign. Those are the rules. So let's just see if it actually works. What we're going to do is we're going to try to add something to both sides of the equal sign, and we're going to see if we have an equivalent statement. If we have an equivalent statement, equivalent meaning the two sides are equal, then we know we can add something to both sides and it still doesn't change it. Or we can multiply, divide, or multiply. Okay, so here we go. Bear, what would you like to add to both sides? You can pick any number. I don't care.
6.
Okay, so we're going to add 6 to both sides. Let's see if we get an equivalent statement. Now remember, for you at home, if I'm writing it, you better be writing it too. All right, so what is 8 plus 6? 14. All right, so that's not too bad. All right, it's equal to. All right, so in PEMDAS or GMA, do we do the parentheses first or do the addition first? Parentheses, okay. So we have 4 plus 4, which happens to be 8. And we still have the plus 6. We've done nothing with the plus 6, so we brought that down. So right now we have the original. 8 is equal to 4 plus 4. We've added 6 to both sides, and we have reconciled this first part right here. 4 plus 4 is 8. All right, so now, just so that we can keep track of what one side of the equal sign is from the other, we have our train tracks, also known as your fence. And the only thing that can go in between the fence is the equal sign. All right, so then, what is 8 plus 6? 14. So that means we still have 14 on the left side, which is equal to, and you told me that is 14. Is that a true statement?
Yes.
Okay. So we can add anything we want, and we just tried 6, but if we picked anything else, it would still work. We can add anything we want to one side, as long as we do the same thing to the other, and we get an equivalent statement. And most of you are looking at me like, no kidding, this is the easiest thing I've ever done. The rules are not hard. Not hard at all. All right, so we're going to go back to our original statement. And our original statement was 8 is equal to 4 plus 4. All right, now we are going to subtract something from both sides. All right, do I have a volunteer to subtract their favorite number from this expression? All right, I have not called on Alex yet. So Alex, you are up. What would you like to subtract from both sides?
This is genuinely my favorite number of 487,985. Seriously.
This is what I think about your favorite number. All right, it hit him in the head. You can't see it, but I swear it did. All right, so Clara, please give me your favorite number.
2.
2.
Oh, come on.
2.
Oh, come on.
So we are going to
I
subtract.
don't blame him. That's a good favorite number.
It is actually a good favorite number, but you know what? I don't want to write it all that out. So
You didn't seem to like it.
not for this video purposes. All right, so I'm going to subtract 2 from both sides. And let's see if I get an equivalent statement. All right, so what is, and obviously this is a new problem, that's why I have the double lines here. What is 8 minus 2?
6.
6. I'm going to continue my train tracks, all right, is equal to. Same idea, 4 plus 4 is 8. So we still have our 8 minus 2, all right. What is 8 minus 2?
6.
So we have 6 is equal to 6. Did it work?
Yes.
All right. We're doing good. This is the best use of the paper ever, don't you think? Let's try another one. Alex, could you put the pen cap on that one? Oh man, took it in the head again. Yeah, I know, he has a big blue line down his nose. I wish you could see it for the camera.
That's not very good.
Wow.
Yeah, I've been throwing a
You're
mortar
supposed to play football.
Well, what you just missed is Alex threw me the blue marker, but it was 5 feet over my head, so you couldn't even see it in the camera. All right, so same thing. We're going to go with Anya's equation of 8 is equal to 4 plus 4. Now, we've proven that adding to both sides, you can do that. You'll get an equivalent statement. Let's try multiplying. Let's try multiplying. All right. Are you going to give me a number that I want to multiply? Or are you going to give me a prisoner number?
Gavin's worse than Alex.
Okay. What are we going to add? Or what are we going to multiply to both sides? 4.
Come on, man. This is boring.
Love it. 4. So we are going to multiply by 4. Now, hopefully last year you were introduced to the multiplication dot.
Yep.
Yes?
Yeah.
Thank goodness. This multiplication dot can be used if you don't want to put numbers together, or if it's not a bad thing to use. All right. So what is 4 times 8?
32.
32. So we get 32 on the left side. Same thing. 4 plus 4 is 8. We still have the times 4. All right. 4 times 8 is?
32.
So we get 32 is equal to 32. Is that a true statement?
Yeah.
All right. So multiplying both sides by 4 gave us an equivalent statement. Do we need to do it for division?
No.
Do you believe me?
Yeah.
Okay. So the rules of the game. You can add, subtract, divide, and multiply anything you want to one side of the expression as long as you do the exactly same thing on the other side. And this is how we show it. Thus the train tracks. This is the expectation. Now, we're going to start a new video that's going to start applying these rules so we can all be winners. All right. Join me for the next video.
Stop.